This video will work through problem 14.5 from Gapenski's Healthcare Finance, 6th edition. So in 14.5, we're asked to evaluate two projects that will allow us to handle provider claims. So these are pure costs. None of them there are no cash inflows. It's all cash outflows. So at time zero, X costs $500 and then $500 in each of the 3 out years. Project Y costs $1,000 and then $300 in each of the out years. So just strictly looking at this, we would, from a, not using time value of money, we'd add the, column X up and be, oh, that's 2,000. Column Y would add up and that's 1,900. Well, it would look like Y would be the preferable choice, but that's not really the complete story, right? So this is not a typical NPV problem. Really what we want to do is simply bring these cash flows back to the present, from out in the future, because $500 3 years from now is not the same thing as $500 today. It's actually something less. And then likewise, the $300 cash flows, bring them back. So let's start with X. And the corporate cost of capital is 500. So, sorry, it's 10%. So let's start with 500, the 500s for X. So payment is 500. Corporate cost of capital is 10, so your interest per year is 10. 3 years, compute PV, and we get 1243. That's the value of the 3 out years plus or minus the additional 500, gets us 1743 present value for project X. Then changing the payment to 300. The value for Y is 746 for the 3 cash flows, minus the $1,000 we pay at time zero gives us 1746. So 1743 is marginally less than 1746. You'd be almost indifferent between these two, but X does win under this circumstance. Now, that's at a PV at 10%. And turns out Project X is regarded as a high-risk project, and the firm applies a 2% penalty to high-risk projects. Now, if this was a normal project where you had an initial investment and then cash inflows, you would want to, the penalty, it would be appropriate to raise the penalty or raise the discount rate from 10 to 12%, because that would make the future cash inflows less valuable. But if we do that here and we charge 12% instead of 10%, what that actually happens is it makes this project look even more appealing because it will reduce the present value of these future cash outflows. So counterintuitively, when we apply a penalty to future negative or cash outflows, we actually want to reduce the discount rate we're applying, not increase it. And so we'd apply an 8% cost of capital or discount rate rather than a 12%. So the now interest rate is going to be 8%, 3 years, and 500 is our payment. Compute the PV, and we get 1288 plus 500, negative 500 for the year zero, and we get 1789. So comparing 1789 to 1746 for Y, now Y is more appealing because Y is less than X, given the applying the penalty of 2% for the riskiness of Y. Sorry, the riskiness of X. Okay.